Hey everybody, this is Mr. Beckstrom, and today I'm going to do a quick video on section 1.3. I believe this is number 59, and this is solve the following equation, and this is an exponential equation. 3 to the 3x minus 4 is equal to 15. They put a little space here, but there really shouldn't be a space. I think that's just a little technical issue copying the problem over. But let's go ahead and see how we solve this. And also I have a little bonus exercise at the end for anybody that's interested. So let's go ahead and talk about this one. So a little tool that we have in our toolbox to use whenever we're solving a problem where we have a variable in the exponent position is that we can take the log of both sides. Now, it's usually beneficial to either take the log base 10 of both sides or the natural log of both sides, which is the log base e. And the reason that we either use one of those two bases is because those are the two bases that most calculators use. And natural log is the one that we most commonly use, and it's because it works really well with e, and e comes up a lot in math. So I'm just going to use the natural log, and the reason that we use the logs is because once we take the natural log of both sides, then we can move exponents out in front of those logs. It's one of the rules of logarithms. So let's go ahead and work on this one. So if I take the natural log of both sides, which we can do in an equation, that's the natural log of 3 to the 3x minus 4 is equal to the natural log of 15. So all I did was just take the natural log of both sides. Now I can move this whole exponent out in front. Now I'm going to go ahead and put this in parentheses to make sure that I distribute it. So 3x minus 4 goes out in front. And remember, you can only do that when we're dealing with any types of logarithms. So 3x minus 4 times the natural log of just 3. We just moved that exponent out to the front is equal to the natural log of 15. Now we can, I'll kind of put parentheses around that just to make sure we know what that is. Now we can distribute this term right here with the natural log of 3. So this is going to be 3x times the natural log of 3 times, or excuse me, this should be a minus there. So that is a minus 4 times the natural log of 3 is equal to the natural log of 15. So all I did was distribute this binomial here with the natural log of 3. Now I just want to get the term with the x by itself and move everything else to the other side of the equal sign. So I'm going to have 3x times the natural log of 3 is equal to 4 times the natural log of 3. All I did was add that 4 natural log of 3 to both sides, plus the natural log of 15. Now I'm going to divide both sides by natural log of 3. So I'm going to get 3x is equal to 4 natural log of 3. And really what I'm going to do is I'm going to divide each term by natural log of 3. It's going to make it a little bit easier because I see it's going to cancel this out over here. And that's really the same thing, plus natural log of 15 divided by the natural log of 3. And that is going to cancel out with that. So I'm going to have 3x is equal to 4 plus the natural log of 15 all over the natural log of 3. And then finally, I am going to multiply each term by 1/3 to get that x by itself, or divide by 3, which is the same thing. So x is equal to 4/3 plus natural log of 15 all over 3 natural log of 3. And if I put that into my calculator and go ahead and round it to 3 decimal places, I'm going to get x is approximately equal to 2.155. And this is an irrational number, so it's going to go on forever. So once again, with this one, I'm just rounding to the first 3 decimal places. So if you want to leave it as an exact answer, you would leave it like this. And if you want to leave it as an approximation, it would be left like this. Now, the interesting thing about this problem is that the actual book had a slightly different looking solution. It had this one. It said x is equal to 5/3 instead of 4/3, 5/3 plus the natural log of 5 divided by 3 natural log of 3. And if you check that in your calculator, you actually get the exact same answer, 2.155, and it will actually be the same decimals, or the same values, even if you go farther out than that. So my question to you, those who want to kind of go a little bit farther in this class, is how did the book come up with this slightly different solution here? Can you work it out in such a way that you come up with the 5/3 plus this instead of the way that I came up with it this way? So that's a kind of a challenge problem with you, and it may come with a little bit of extra credit. And if you want to put it in the forums, be my guest. All right, thank you, and have a great rest of your week.